Hello everyone. Today we continue with the solutions. The topic solutions. Okay. So already we have discussed about what now different types of concepts of what now concentration terms. Okay. So today we once again revise whatever we need. Okay, for this examination. Okay, man. So listen carefully. Now see, generally what now solute less in quantity, solvent more in quantity to give what solution. Okay, that we know. Now major component, minor component will give solution. Homogeneous mixture. Solution is what homogeneous mixture. Next one. So examples of different types of solutions. If they say syrup, suppose syrup means what now? A solution of water and sugar. A solution of water. A solution of water and sugar is called what now here? Syrup you take. So what is the syrup here? A solution of water and sugar is called syrup. In this sugar is what? Solute. Water is solvent. Next one. A solution of, here in this case now here, syrup, sugar is solid here. The solid in water, liquid. Solid in liquid type of solution it is. Next. A solution of sodium chloride, that is common salt, common table salt. Okay, in water is called brine, remember. B-R-I-N-E, brine. So brine indicates what, ma? Brine indicates what? Brine indicates it is a solution of what and what? It is a solution of sodium chloride in water. B-R-I-N-E, brine. And syrup indicates what? Solution of sugar in water. Next, a solution of carbon dioxide in water is called Seltzer. Seltzer. Okay, solution of carbon dioxide in water is called Seltzer. So generally what now here, the soda water is nothing but carbon dioxide gas in water is called what now here? Seltzer. Next, a solution of ammonia gas in water. Ammonia gas in water. So gas in water type. Ammonia gas in water is called what now? Liquor ammonia. What is that? Liquor ammonia. So liquor ammonia is nothing but ammonia gas dissolved in water. It's called liquor ammonia. So these names you have to remember. Next, classification of what your solutions. Another type of classification of solutions is what you're based on the type of solvent. Based on type of solvent, solutions are of two types. How many types of solutions? Two types of solutions based on type of solvent. Okay. Now see here. Suppose aqueous solution. Aqueous solution means what? A solution in which water is the solvent. Water is acting as solvent here. If water is the solvent, that is called what now here? Aqueous solution. Okay. Next, alcoholic solution. So a solution in which alcohol is the solvent. Alcohol is solvent, which is called alcoholic solution. If alcohol is the solvent, that is called alcoholic solution. If water is the solvent, it is called what? Aqueous solution. That point keep in mind. Next, classification, another type of classification. It is based on what? This classification based on amount of solute. Amount of solute dissolved in a solution. How much amount of solute is dissolved in given solution will decide what now types of solution. So first one, saturated solution. Saturated solution. So in saturated solution, what we have to understand is that a solution which cannot dissolve any more solute. Okay, a solution which cannot dissolve further any more solute at a given temperature is called what now here? Saturated solution. The saturated solution contains the amount of solute which is exactly required for saturation. For saturation of solution, exactly how much amount of solute is required, that much amount is present. Then it is called what now? Saturated solution. The next one, unsaturated solution. Unsaturated solution. A solution which can dissolve some more amount of solute, at the given temperature. If a solution is ready to dissolve some more amount, that is called what now here? Unsaturated. It's known as unsaturated solution. Got it, ma? A solution which cannot dissolve any more solute at a given temperature is called what? Saturated. But unsaturated means a solution which can dissolve some more solute at the given temperature is called what? Unsaturated solution. Next, supersaturated solution. A solution which has excess of solute, which has already dissolved what? Excess of solute. Already excess of solute is dissolved in this. A solution which has excess of solute dissolved in it. Okay, then that is required for its saturation. than for saturation, than required for saturation, more amount will be dissolved here. If a solution contains the excess amount of solute, which is more than required for saturation. Okay, in such case, that solution is called supersaturated solution. So supersaturated solution contains more solute than required. Unsaturated solution contains less solute required, less solute than required for saturation. Unsaturated solution contains the amount of solute less than required for saturation. And saturated solution exactly contains the quantity of solute which is required for saturation of solution. And here, remember that this supersaturated solution is what now here? Unstable. Supersaturated solution is what? Unstable solution. So it is called metastable solution, we say. Metastable solution. So metastable meaning what, ma? Unstable. Remember, metastable means unstable. So which is unstable solution among the three types here? Supersaturated, because already excess amount of solute is dissolved. That excess solute may come outside at any time. Okay, if you change the conditions of what here, temperature and addition of some more solute like that, the excess dissolved solute will come outside from supersaturated solution. So supersaturated solution is less stable, unstable, metastable, we say. Is that clear, ma? Now, one more thing what you have to remember is that in this saturated solution, there will be a dynamic equilibrium. Which equilibrium? Dynamic equilibrium. So dynamic equilibrium exists in what? Saturated solution. So this saturated solution, suppose if you take what now here, a vessel we have taken. So in this vessel, it is solution here. Now it is solution. Okay. Now in this solution, here some amount of solute is undissolved. It is undissolved solute, undissolved solute at the bottom. Now this solution is what now? The solution is what now? Saturated solution. Remember, saturated solution. The solution is saturated, but the excess, whatever we added excess solute, the excess solute has gone to the bottom, settled at the bottom. This is undissolved solute and a saturated solution. Is saturated solution. Now in this saturated solution, which particles are there here? The solute particles there here. Now it is dissolved solute. Dissolved solute. So dissolved solute particles. So dissolved solute is there in the solution, and at the bottom some undissolved solute also is there. In the solution some solute is there which is dissolved, and at the bottom of the solution some undissolved excess solute is there. Now what happens is that from this undissolved state, okay, the particles will go to dissolved state. From undissolved state, the particles will go to dissolved state. Again from dissolved state, the particles will come to undissolved state. Are you able to follow? Suppose from this undissolved solute at the bottom, 10 particles entering into solution. 10 particles enter into solution from undissolved solute, suppose. Then from solution also, 10 particles will come to undissolved state. If 10 particles from undissolved state will go into solution, the same number of 10 particles will come to undissolved state from solution. That means from undissolved state to solution state and solution state to undissolved state, same number of particles will be moving. That is why it is called dynamic equilibrium. So the dynamic equilibrium will exist in what? Saturated solution. That point keep in mind. Okay, these three types of solutions you have to understand. Next, conversion of one type of solution to other. Means saturated into unsaturated like this. See here, a saturated solution can be converted to an unsaturated solution. Saturated to unsaturated. The conversion is from where to where? Saturated solution to unsaturated. First of all, try to understand what is saturated. Here, exactly required amount will be there. In saturated solution, how much solute will be there? It contains, saturated solution contains what? Required amount of solute. Required amount of what? Solute. Required amount of solute is present in saturated. And in unsaturated, what is there? Less than required. Less than required solute is there. less than required. So solute which is less than required is there in unsaturated. Now, how to convert saturated into unsaturated, we have to understand. Now, see here, first method is what? By heating the saturated solution. By heating the saturated solution slowly. By heating saturated solution slowly, what happens? It becomes what? Unsaturated. Remember. What is the reason here? A saturated solution can dissolve more of the solute at higher temperature. At a particular temperature, it cannot dissolve more. At a particular temperature, saturated cannot dissolve more amount. But at higher temperature, when you increase temperature on heating temperature will become high now. At high temperature, the saturated solution can dissolve some more amount. Then it becomes what? Unsaturated. Already required amount is there in saturated. From that required amount, okay, some more will be dissolved completely. That means it becomes what now here? Unsaturated. The saturated becomes unsaturated by heating the saturated solution slowly. Remember, by heating saturated solution slowly, it becomes what? Unsaturated. That point keep in mind. First thing. Second thing, by adding more solvent, to the saturated solution. To the saturated solution, what we are adding? More solvent, more water is added here. More solvent means more water is added. If we add more solvent to the saturated solution, it becomes what? Unsaturated. It becomes what? Unsaturated. So saturated can be converted into unsaturated by heating the saturated solution slowly, and also by adding some more solvent to the saturated solution. So this is important concept here. Remember, this is not confused. Next, a saturated solution can be converted to supersaturated solution. Now, saturated to supersaturated solution by which process? By cooling process. By cooling the saturated solution, it becomes what? Supersaturated. So remember that here I'm taking saturated solution. What I'm taking? Saturated solution. This saturated solution becomes what and what? On heating, slowly it becomes what? It becomes unsaturated. So it becomes unsaturated by heating, and by cooling, the same saturated solution becomes what? Supersaturated. So this point mainly you have to understand. Supersaturated solution. Is the concept clear to all? How to convert the saturated to unsaturated and saturated to supersaturated, we have to understand. Okay. Next, true solutions. Generally, true solution meaning what? You mean by true solution? The particle size will be less or more. I told you, true solutions will be there, colloids are there, and suspensions there. In which case, the particle size will be least, smallest size will be for true solution. See here, now we are discussing about true solutions here. True solution means homogeneous. True solutions are what? Homogeneous mixtures. Homogeneous. So homogeneous mixture of two or more components is called true solution. The following are the characteristics of true solutions. First one, what? Nature of true solution. It is homogeneous in nature. The true solution is what? Homogeneous in nature, means thoroughly mixed. All the components are thoroughly mixed. Okay, next, particle size. The particle size is molecular and particles. Okay, the particle size will be molecular size or particle size, atomic size or molecular size. Very small size will be there here. So remember that the particle size, what I told you, less than 1 nanometer. Less than 1 nanometer. So 1 nanometer means how many meters? The same thing out right now, less than 10 power minus 9 meters. 1 nanometer is equal to 10 power minus 9 meters. Less than 10 power minus 9 means it should be 10 power minus 10 or 10 power minus 8. Less than 10 power minus 9 means it should be 10 power minus 10 or 10 power minus 8. That is, yeah, 10 power less than 1, 10 power minus 9, that is what we understand, 10 power minus 10 or 10 power minus 11, like this. These are lesser values, lesser than 10 power minus 9. So 10 power minus 10 is smaller than what? 10 power minus 9. like that. So less than this value should be there, the particle size. Then it is called true solution. And these particles can pass through the pores of filter paper. When you filter the true solution, the residue will not be obtained. The residue will not be obtained on the paper. All the particles will go through the holes of the filter paper. Pores means what? Holes. So the holes of filter paper, all these molecules will pass through. The particles of true solution will pass through what? They will pass through filter paper. That's why we cannot filtrate the true solution. Next, cannot be seen under microscope. Even under microscope, we cannot see the particles of true solution. That means the particles of true solution are tiny particles, very small particles, and they do not settle down at the bottom of the vessel. The true solution will not settle. The particles of the true solution will not be settled at the bottom. Okay, so this is all you have to understand. Next one, yes, separation of these particles of solute and solvent from true solution. So solute can be recovered from the solvent by physical and not by chemical methods. By physical but not chemical methods. The solute can be recovered from the solvent by physical and not by chemical methods. Okay, so these points here, remember about what now here, true solution. Next one here, note. One important note is what? A true solution is a mixture. A true solution is a mixture and not a compound. True solution is not the compound ma. It is a mixture of what? Two or more compounds. Here, two or more solutes or two or more components. Okay, always the solution will contain what? Solute and solvent. Solute and solvent. So this mixture may be containing what now? One solvent will be there in this place. Okay, one or more solute particles, one or more solutes and one solvent. Always how many solvents in the given solution? Only one solvent will be there, remaining all will be solutes. Next, the solubility of the solute is given by S. Okay, see here, definition of this solubility is given by solubility is the amount of solute that dissolves, in a unit volume of solvent. Unit volume means what now? Particular volume, 1 ml, 1 liter, 100 ml like this. In the given volume of solvent, in the unit volume of solvent, the amount of solute that can dissolve to form what? Saturated solution, to give saturated solution. Okay, at a specific temperature and pressure is known as what? Solubility of the solute. Suppose if we take what now? 30 grams of solute, 30 grams of solute X, plus unit volume of solvent. Unit volume of what? Solvent. In the unit volume of solvent, what is dissolved? In the unit volume of solvent, in the particular volume of solvent, how much of solute is dissolved? 30 grams of solute is dissolved. So the amount of solute that dissolved in unit volume of what here? Solvent, to give what? Saturated solution. Now what is formed? Saturated solution of that solute. Saturated solution is formed here. To get this saturated solution, how much amount of solute is required here? 30 grams. So 30 will be solubility. Therefore, solubility is what now here? Therefore, solubility of X. Solubility of X is equal to 30, we say. Solubility of X is equal to what? 30. What does it mean here? 30 grams of that solute is required to be dissolved in unit volume of solvent to get which type of solution? To get saturated solution. So to get saturated solution, 30 grams of that amount of solute is required. Therefore, the solubility should be taken as what? 30. Now see here, thus the solubility formula you see. Solubility of solute is equal to, solubility means S. Solubility of solute is equal to amount of solute by amount of solvent into 100 you take. Amount of solute by amount of solvent into 100. Amount of solute in grams you take, amount of solvent in grams you take into 100. This is what our solubility formula. So tell me solubility formula. Amount of solute in grams. W2 means weight of solute. 2 means solute. 1 means solvent. I told you. W2 means weight of solute in grams by weight of solvent in grams. Weight of solvent. W1 meaning what? Weight of solvent into 100. Into 100. The same thing in place of 1 and 2. What we take? A and B we take. The same how to write now. Weight of solute. A for solvent. B for solute. A for AR1 will be for solvent and B or 2 will be for solute. Okay, now in this way, now what we take in place of weight of solute, what we take WB in grams. WB in grams by WA, weight of solvent in grams. Into what now? Into 100. That means what now here, how to define this? Solubility is the weight of solute. The weight of solute in grams present in 100 grams of solvent. Weight of solute in grams present in 100 grams of what? Solvent is called what? Solubility. Okay. Now these are important areas to understand here. Next one. Factors affecting solubility. Which factors will affect the solubility of the solute? So first one, nature of solute and nature of solvent. Nature of solute and solvent will decide what? The solubility. Like dissolves like means what? Polar substances. Sorry. Polar. So polar solute can dissolve in polar solvent only. Polar solvent. So polar solute can dissolve only in polar solvent. Polar solute can dissolve only in polar solvent. So like dissolves like here. So here polar solute can dissolve in polar solvent to give solution. And non-polar substance, non-polar solute can dissolve in non-polar solvent only. Okay, like this you have to understand. So like dissolves like. Okay, so polar solutes dissolve in polar solvents and non-polar solutes dissolve in non-polar solvents. And non-polar solutes do not dissolve. Non-polar solutes do not dissolve in polar solvent. And polar solutes do not dissolve in non-polar solvents. Is that clear, ma? Like dissolves like. Next one, size of solute particles. Okay, ma. So the size of solute particles also will decide what? Solubility effect. Solubility will be decided by size of solute particles. So now see here, dissolution is a surface phenomena. Dissolution is what? Not bulk phenomena. It is surface phenomena. Like the evaporation. If you take evaporation and boiling, evaporation and solubility. Evaporation, dissolution take. Evaporation and dissolution. These two are what? Tell me. Surface phenomena. Surface phenomena, what are they? Only evaporation, dissolution. Next one, boiling is what now here? Bulk phenomena. Boiling is what? Bulk phenomena, remember. So boiling is bulk phenomena. This point you have to understand here. So boiling is bulk phenomena, whereas evaporation and dissolution are surface phenomena. Okay, now see here, listen carefully. So now the surface area of a solid solute, can be increased by converting it into powder. So if we convert the solid into powder, we have taken this much, and it became what now? Powder. The solid is converted into powder here. So many powder particles are there here. Okay, it is about powder here. It is solid here. One piece of solid. Now here, if you take the surface area of this total solid, it will be less when you compare with the total surface area of all the particles. The total surface area of all the particles, if you take, that will be greater than the surface area of the solid. So here in the powder form, what will be there? More surface area. So in case of powder, what will be there? More surface area. So more the surface area, more solubility. More the surface area, more solubility, remember. So the solubility will be more if surface area is greater. So more the surface area, more solubility. That point keep in mind. So that's the powder is easily soluble than what? Solid. Okay. So the powdered solute dissolves more easily. The powdered solute dissolves what? More easily than what? The large crystals. The large crystals will be less soluble, but powder will be more soluble. As in the former case, former means what now here? The powder. Former means what is mentioned first here. Whatever is mentioned first is what? Former. Powder is mentioned first here in this above sentence. And what is mentioned later here? This one. It is crystal later. So, as in the former case, larger surface area is in contact with solvent. So, former case, what is this? A powder. In powder, this particle is there, this particle, like this, many particles are there. Na? If you take the total surface area of all the particles here, so the surface area, more surface area of the particles will be in contact with water, solvent. That's why more easily soluble here. So, former case means what? This one. And this crystal is mentioned later now here. This one is called later here. Later case. Later means what now here? Whatever is mentioned later. Whatever is mentioned second time is called later. Whatever is mentioned first time in the above sentence is called former. Okay. So here, LATT, later case. In later case, what now here? Surface area is less. Surface area is less and less solubility. Surface area less solubility in crystal, in case of crystal. And don't confuse with this word. LATER. Later means what? Afterwards. After next is called later. Next means immediate next. After next it is called later. LATER. But it is what now here? LATTER. Later means what? The second time mentioned in the above sentence. Okay? That point keep in mind. So it's about what now here? The particle size of the solids. Now, hesitation of mixture. Hesitation of mixture. So stirring means mixing, hesitation. With spoon we stir na, the tea is stirred with spoon, like that here. So the stirring process speeds up dissolution. It will speed up the dissolution process. The reason is on stirring, on mixing, on hesitation, what happens now? The saturated solution, okay, surrounding the solute particles diffused away, and fresh solvent or unsaturated solution takes place. So when you're stirring, what happens now here? The saturated becomes what? Unsaturated. By hesitation in the saturated solution, it becomes what? Supersaturated. Okay, saturated becomes what? Unsaturated. Saturated becomes what here? Unsaturated by hesitation. Thus, more solute dissolves in it. Okay, by hesitation, what happens, ma? More solute will be dissolved. Okay, note. Small size of solute particles and hesitation. Small size of solute particles will favor dissolution, and hesitation of mixture will reduce the time taken for dissolution. Time taken for dissolution is reduced means the dissolution is fast. Dissolution is fast, indicating what? The time taken for dissolution is less, meaning what? In less time only, the total solute will be dissolved. That point keep in mind. So these do not change the solubility of solute. Okay, so they will not change what? The solubility of solute. Okay, so the solubility of the size of solute particles and hesitation will reduce the time for dissolution. Will reduce the time for dissolution. When time taken for dissolution is less, what happens now? We say that the solubility is very fast actually, but actually solubility will not be changed. Solubility value will not be changed. The solubility value remains what? Same, but the dissolution takes place very fast when the particle size is less and hesitation occurs. This point we have to clearly understand here. Now another factor is what? Temperature. Okay, so before understanding the effect of temperature on solubility, let us know about endothermic and exothermic reactions, or endothermic solution, exothermic solution. When solution is formed, if heat energy is released, that is called what? Exothermic solution. When solution is formed, if heat energy is absorbed, that is called what now? Endothermic solution. Okay, if heat energy is absorbed for the formation of solution, that is called endothermic. If heat energy is released during formation of solution, it is called exothermic solution. Now, endothermic solutions, the solutions that are formed by the absorption of heat, like this, by the absorption of heat from the surroundings, are called endothermic solutions. Example, when ammonium chloride, NH4Cl, when ammonium chloride or silver nitrate, AgNO3, silver nitrate formed what? AgNO3. When ammonium chloride or AgNO3 is dissolved in water, water is what? Solvent here. The solution gets cooled. The solution gets what? Cooled. That means heat energy is absorbed. Cooled meaning what here? Heat energy is absorbed. Okay, so as heat energy is absorbed, what happened here? The cooling effect occurred here. That's ammonium chloride. When dissolved in water liquid, it becomes what? What here? Heat energy will be absorbed. Here, product minus heat. What we wrote here? Product minus heat. Product minus heat means what? Endothermic reaction. Remember, product minus heat means endothermic. If you write, suppose product plus heat, if you write, it is exothermic reaction. Product plus heat indicates what? Exothermic reaction. Product minus heat indicates what? Endothermic reaction. So this difference try to understand. Okay, ma? Next one. For such solutions, solubility increases on increasing temperature. Now, solubility is directly proportional to what? Solubility directly proportional to what? Temperature. When solubility increases, when temperature increases, solubility will increase. For which type of solutions? For such solutions means what? Endothermic solutions. For endothermic solutions, the solubility and temperature directly proportional. Remember. And next type is what? Exothermic solutions. The solutions that are formed by the evolution of heat. Evolution meaning what? Release. By the release of heat. Okay. By the release of heat, if heat energy is released, that is called what? So release of heat. Evolution means release. So by the release of heat energy, if solution is formed, that is called what? Exothermic solution. Okay. The heat will be released to what? Surroundings. So the solutions that are formed by the evolution of heat to the surroundings are known as what? Exothermic solutions. Example what here? When calcium oxide, CaO, calcium oxide, or lithium carbonate formula what? Li2CO3. When lithium carbonate or calcium oxide is placed in water, okay, what happens? The solution gets heated. The solution is getting heated means what is happening here? Heat energy is released here. That's why a product plus heat. Product plus heat we wrote. That's why it is what now? Exothermic reaction. Okay. For such solutions, the solubility decreases on increase of temperature. So solubility is inversely proportional to what? Temperature here for exothermic reactions. For endothermic, what? Solubility is directly proportional to temperature. So solubility is directly proportional to temperature for what? Endothermic solutions. For endothermic solutions, solubility and temperature directly proportional. So up to this concept you have to understand. Okay. Bye. Good day.